In the world of software, some of the most dangerous bugs aren't the big, complex, sophisticated ones. Nope. They're the simple, almost invisible mistakes that are hiding in plain sight. Today, we're looking at one of the sneakiest, variable shadowing. It sounds a little mysterious, and trust me, it can be absolutely catastrophic. Get this. What if I told you that a single subtle coding mistake, a bug so well hidden it's practically invisible, could end up costing a company $10 million? Sounds wild, right? Like something out of a movie. But it's a very, very real problem that developers deal with. So that's the big question, isn't it? How can one tiny, hidden line of code spiral into such a massive disaster? That's the mystery we're going to solve in this explainer. We're going to dig into exactly how this little error can cause a total meltdown, and more importantly, how you can stop it.
All right, let's dive in. We need to identify our prime suspect here. And in the programming world, it has a name: variable shadowing. That's the technical term for the culprit behind all this multi-million-dollar chaos. So what is it exactly? Well, to put it simply, variable shadowing is what happens when a variable in a small, specific part of a program, say inside a single function, accidentally hides or shadows another variable that has the exact same name, but exists in a bigger, broader part of the program.
The easiest way to think about it is like this. Imagine you're at a party with your friend Alex. Then you walk into the kitchen, and guess what? There's another person in there, also named Alex. If you shout, "Hey Alex, who are you talking to?" You're talking to the Alex right there in the kitchen with you. The program does the exact same thing. It just defaults to the closest Alex, basically forgetting the other one even exists. And that's variable shadowing. Okay, so let's play detective for a minute. To really understand how this digital trickery works, we have to go right to the scene of the crime, the code itself.
So here's our setup. In the main part of a program, we'll call that the outer scope. We have a variable called count, and its value is 10. Simple enough. But then deep inside a specific function, the inner scope, a developer creates a new variable, and they also call it count. But this one has a value of 100. You can probably see where this is going. The conflict is set.
And here's how it all plays out. First, that original count variable gets created, its value is 10. Then, inside our function, the new shadow count pops into existence, set to 100. Now, and this is the crucial part. Any code inside that function will only see the local shadow version. It is completely blind to the original one. And that is where the disaster strikes. If that function is part of, say, a financial calculation that's expecting a value of 10 but it gets 100 instead, well, you can see how the numbers can get very wrong very, very fast.
And this quote really nails why this is such a headache. It's not just that the bug can be expensive, it's that it's unbelievably sneaky. The code itself can look totally fine. There are no obvious errors. A developer could spend weeks hunting for the problem without ever realizing it's just a simple case of mistaken identity.
So, if this culprit is so good at hiding, how in the world do you catch it? Well, luckily, developers have a whole toolkit designed specifically to spot these shadows before they can do any real damage.
Spotting a shadow really comes down to a combination of automated tools and good old-fashioned human vigilance. Developers use these cool programs called linters that automatically scan code and flag potential problems, including shadowing. But honestly, nothing beats a careful code review, where a second pair of human eyes can look for things like reused names. At the end of the day, having clear, consistent naming rules is a programmer's #1 defense.
And what if you actually find a shadow? Well, the great news is the fixes are usually surprisingly simple. The easiest, most common solution is to just rename one of the variables to be more specific. So instead of just count, maybe you call it total count or local count. Other fixes involve just simplifying the code so there's less nesting. Or in some languages, you can even use a special keyword to tell the program, hey, no, not that Alex, I mean the other Alex out in the hallway.
But really, the ultimate defense against variable shadowing, and a whole lot of other bugs for that matter, is to write code that isn't just for machines, but for people. Code that's clear, precise, and easy for another human being to read and understand. That's the kind of code that's much less likely to hide these expensive, frustrating little secrets.
And this whole idea of a hidden conflict, a simple misunderstanding buried deep inside a system, it goes way beyond just code. Variable shadowing is just one example. It really makes you wonder. From our financial markets to our social networks,
What other shadows, what other subtle, hidden conflicts are lurking deep inside the complex systems we all depend on every single day?